absolutely radical different technology. So what made it different? The first 1.5 millimeter blade on the market, laser cut, anti-vibration, so you don't have the vibration on it, perma-shield coating, Tyco carbide, goes on, and how much technology was in this blade. So Freud, our history, we make up to 800 millimeter blades. Blades are literally this tall. And we dominate, the manufacturers in the industry where they're, having literally 13, 15 stacks of melamine, cutting 8 hours a day, 3 shifts a day over and over and over, and we dominated that business. But this was one of our biggest advancements and achievement, is putting all this technology to be able to retail it for $9.99, right, $10. So that was strong. But everybody keeps asking us, what are you guys doing about this cordless phenomenon, right? All the power tool companies are saying, cut the cord, cut the cord. How are you preparing for that? In addition, more and more micro lambs, super lambs are being put in materials, right? Just cutting clean wood is becoming more, it's becoming less and less of an application, and cutting the extreme materials are becoming more and more of a challenge, right? So this is an opportunity. So everybody's like, what are you going to do about preparing for cordless? Well, let's take a look at what's happening right now with standard saw blades in the marketplace. ATB, you guys familiar with ATB, right? Saw blade top. So basically what you have is a couple of Batman ears, right? You have a right and a left that alternate when you're cutting. Cut right, cut left, cut right, cut left. And what you have is this natural tension. It's pulling back and forth. It works good in the application, but we started challenging ourselves and say, what could we do to improve this tensioning? How can we make this blade cut more efficient? And so I think we've done that, and we're excited about launching this new next generation. Roll video. So we're introducing a new tracking point. You okay, Kevin?
I'm good.
Okay.
I'm good.
Kevin got a little scared about going in the water after he saw that on that application. So what we've done, what this new design is, every third tooth, we're putting what we're calling a tracking point design in it. So it kind of operates like this. And the way to think of this is simply like a rudder. And a rudder, so when you're pulling right, left, that rudder in between just keeps the blade tracking much more true. And so the vibration has been significantly reduced. And the performance we're getting is dramatic just by doing this. Now it's complicated because versus a right and a left where you're having, this is only one grind. When you do this tracking point, you're putting 2 grinds for every third tooth. So in effect, on every 24 tooth blade, we're adding 8 additional grinds to be able to do that. Also, your tolerances must remain within 0.001. which is there is no room for error. And if you're off just a little bit, what happens on a boat rudder? When you're turned a little bit, you're going to cut circles, right? Right? That's not a good thing. So it is a technology play that is dramatic, but you need to make sure you have extreme level of tolerances to be able to maintain this performance. And we're going to maintain the same retail price point of $10 or $9.99. We like to say $10, $9.99. That's a big difference. So to illustrate what we're going to do is we have, and this is, hopefully you're going to get excited about this. So we're going to illustrate in a gravity-fed sled with 2 cordless tools. We put a DeWalt blade on here. DeWalt's a good blade. There's nothing wrong with this DeWalt blade. We're going to show you the difference of this new performance, okay? And what we're going to do is we're going to measure volts. How many volts are in the battery pack from the beginning and to how many volts are actually used in making the cut. And Steve, you can just move the side. It's just going to be simple. The software program on a Bluetooth is going to run. It's going to measure at the beginning and at the end. How much is the tool sucking out and using to make that application? All right? And then we're going to show you that comparison. So, and to illustrate, let's just quickly run the slide. Yeah, sure. I mean, Freud, we're very big on integrity, everything that we're doing. But this is really simple. We're going to just let it run down. And you can see that, yeah, just go ahead. That's a catch and pitch. So it just all slides. When there's no wood in the way, it's going to all move at the same pace. Right? So now we're going to hopefully drop the blade into the material and drop it down. We'll calculate this and see what does cutting more efficient, what does it do in a cordless application. Now, as we're setting this up, remember, learning or figuring out how to cut more efficient is good for the whole industry, for corded and cordless. For your motor on your battery power, it should not be limited to just cordless. And I think what we're focused on for the future is really all about efficiency. And efficiency is good for every tool out there. And that's what we really want to focus on in terms of that. There's benefits all the way around. So are you ready?
Ready.
Let's see what happens. Give it a go.
Here we go.
Big difference, huh?
There we go.
Now, to me, it seemed like it got held up a little bit on that at the beginning. Could have been a knot or whatever the case is. The point is, you're going to see a dramatic difference. So much so, we're going to go out, we'll market that you'll get at least 45% longer, more efficiency out of this thing. In this case, that was 65%. That was a little higher than normal.
Yeah.
So luckily, usually when you guys are around, it never works. This is, I don't know what's going on. This never happens. That's dramatically. So 65% less power means you get 65% more cuts per charge. Now in an industry where power tools are running out and screaming, look at our 5.0 battery technology, we're going to give you 5%, 7% more run time, more charge, more life on the battery. You can, by simply putting a different saw blade on, you can extend it by 50%. And that's pretty dramatic. So we're excited about that, and you'll see us get very noisy about this. So that's good, right? That's a very common application. Very application here. You're going to cut bolts, nails. You're going to flashing. You're going to have this asphalt shingles out there. This is just reality. You'll hit gusset plates out there. There's no such thing as clean wood when you're out there in the world. So if we go out there, we cut efficient. How will it hold up in a durable situation? So to illustrate this, what we're doing is we're going to compare ourselves versus Irwin's Marathon Weldtech. You guys familiar with this, Weldtech? Weldtech, the idea is very, very good. So the Weldtech said, hey, we're going to keep our teeth on longer in an extreme durable application. So the teeth don't fly off, basically. And so there's nothing wrong with this blade. We're going to show you how we're different. But this blade will retail between $12 to $15. Okay? So we'll just make now, how are we doing?
I think right here we should be.
Yeah.
I'm going to block.
Yeah, you got to block.
I've got you. Protect
So
you.
let's see. Let's make a quick cut here, Matt, and we'll go from there. So we're moving into an unsafe cut.
What
gave that away, Russell?
You're probably saying it started as an unsafe cut, but this is a realistic type of application, right? So you can see how difficult it was cutting. You can see the sparks. You can see the smoke. So now we're going to try this new tracking point in the same application. And then we'll show you the two. And of course, the bolts go in. They don't stop like right here. They actually go 4 or 5 inches too. And then we'll actually make a cut, and then we'll show you. We'll compare the difference. But before you start, I mean, look at the sparks that you're seeing. Listen to the sound, and look at the smoke when it's cutting. Hopefully, the lack of. Excuse me. these guys were doing the wave back there, but we had to shut that down. So look at the difference. Listen how clean that was. And when the blade, instead of going like this, and when you're cutting the bolts and you're cutting vibration, you have a lot of bad things going on. You can actually see another blade there. When the weld tech was cutting this, it was really having a tough time. It was burning and struggling. Very, very clean. In fact, we can easily get another cut. You guys want to see another cut?
Yeah.
Sure.
Sure.
Let's do one more. Let's do one more.
Oh, yeah.
I could have stopped. Yeah. Go for this. Some non-ferrous, which is called a triple for a new design. This tracking point, even on the bigger blade that you get, when it aligns it better, you cut more efficient, good things happen. And so it's interesting that some of the Diablo project actually went up to our industrial business, because usually, being an industrial company, you can't market your way in the industrial business. You can't promote your way in the industrial business. They put it on within minutes. They're going to know, does it work or does it? And if it doesn't work, they take it off and they say no. And so Freud dominates in the industrial, and usually the product development, food chain starts there and ends up at the Diablo. This is kind of a fun one. It actually started Diablo and worked its way up. And so, hey, good ideas. We don't care where they come from. We love it. But it's exciting new technology for us. Very difficult to maintain that. But we're excited about what we're able to do. Massimo here is our lead engineer on this project, and we're getting really good results. He's already working on next generation. In fact, we're already in prototype development, the next generation. So we're not going to slow down. We want to make sure we keep pushing the envelope. I do think for the future, you're going to see all common geometries and blades disappear, and it's going to be extremely complex geometries, very, very difficult to make, but hopefully huge, huge benefits for that. And then we're committed on maintaining our price points, because technology is great, but it's got to be at an affordable price with that. So.
Russell, are you able to do this on the 6.5-inch blades?
Very good question. So we'll start with the 7 1/4, 24 tooth. We'll expand it down the road, definitely. It is a big undertaking. As you can imagine, the loss of efficiency when you just add 8 more grinds. So on a 24 tooth, think about that. It's almost a 50% adder. So we're going to take a big hit on that, but then we'll roll it out absolutely to any of the 24 tooth models. On the 40 and the 60 tooth and the higher tooth geometries, we have a little bit more work to do on that to make sure we're getting the right finish in that application. So we need a little bit more development time in that. We're concerned that we could lose a little finish. We don't know that yet. But down the road, this will be a big part of our future, definitely.
So the 6.5-inch will be 24 tooth also?
Yeah, and 6.5. We have it today. We just have it in the regular. We just don't have this tracking point, but we will.
Is it 1.6 millimeter also?
1.5 millimeter. So it's a 1 mil steel body, 1.5 clearance. So you have a 0.5 millimeter clearance for both sides. So your kerf is 1.5 millimeter. So in the industry, it's not about just making a thin kerf. You have to maintain the integrity. So the thinner is great, but if it starts flopping around a little bit, or you can't, it's a real, it's easier to braze to a thicker piece of steel, and very complicated the thinner the steel is to braze and maintain that durability. So it's not so easy just to go thinner kerf. We'll push the envelope in terms of kerf thickness for the future. Thinner is always better if you maintain your integrity or durability. Good things happen. But sometimes we can outskill our users. I mean that. Hopefully in the right spirit, because woodworkers are very precision oriented. Our contractors can be sometimes cowboys, and they want to push the tool as hard as it'll go. And sometimes when you design something more efficient, it is a new technique to learn to let the tool do the work. But a lot of our users will look at that and they say, no, I want to go as fast as this tool will let me. And then that can cause sometimes some tricky things. All over the place. But we're excited about it. It's gonna get fun, and, you know, we already know we're gonna introduce next year. So, love to see everybody next year, because we're gonna do it again in a big way. What else? What other questions? Well, thanks for coming. Oh, what, Rob?
So in terms of market penetration, with the original Diablo blade,
Yeah.
how did that perform, and where do you see this going?
Yeah, so, you know, the facts and figures, I think it is very conservative to say that Diablo's over 50% of the market. And we electively don't sell 27% of the market. We don't feel it fits our model. So we walk away from
That's
our
the bottom
reach.
end,
Pardon?
presumably. The bottom end, you're not even making blades for the bottom end of
No.
the price point.
No, we do not manufacture blades of that. Now, we have a range called Avanti Pro, which are buyout product on there, but all of our manufacturing is on either a Diablo or a Freud products that we put out there. So just referencing Diablo, I think it's safe to say we're north of 50% of the market. So Diablo came in and absolutely dominated, just offering it at a very competitive price point, just a significant different solution. And the numbers every year that it takes share is really significant. So it's been very good for us. And remember, Diablo is positioned to the contractor. If you drive to your job and work in an outside environment, in a harsh environment, that's Diablo. If you go to a fixed, established place to make your living, 3 horsepower or greater in terms of tools that you're using, that's the Freud industrial market. So it's not that Diablo is a lower cost Freud, that's not it at all. Diablo is premium for portable power tool arena, and Freud is premium for, call it, a stationary industrial tool arena. That makes sense. No other manufacturer can market to both, because they just don't simply have the technology to do that. And yet everybody tries, so we want to keep making sure that we make it difficult.